Alright, so let's review real quick the classification of matter before we look at our examples. So remember, matter is anything that can take up space and has mass. Now, first question is, ask yourself, does the matter have constant properties and composition? Because if yes, it falls in the pure substance category. More specifically, ask yourself, can it be simplified chemically? Because if it can't, you've reached an element, which remember, the element is the most basic building block of all types of matter. But if it can be simplified chemically, then you're looking at a compound. For example, H2O is a pure substance, but it can be simplified chemically down to just hydrogen and oxygen. On the other side, does it have a constant properties and composition? If you answered no, you have a mixture. For example, salt water. Salt water has salt and water, both of which have their own chemistry property and compositions, so it would be a mixture. But ask yourself, is it uniform throughout? If it is uniform throughout, like salt water is, you've reached a homogeneous mixture. If it's not the same throughout, you've reached a heterogeneous mixture. So with that being said, let's take a look at some examples. Example 1. Determine if the following is an element, compound, heterogeneous mixture, or homogeneous mixture. So taking a look at the first one, deionized water. Notice that it says deionized water, which would imply that ions have been removed. If I said tap water, the water that comes out of your sink, you might know that it's not just water, it's got a lot of ions in there to keep it clean. Well, when we talk about deionized water, we're strictly just talking about pure water. And so in that case, deionized water would be classified as a compound. There's nothing else in there other than just the water particles. The next one, 2012 penny. Now that might sound really random, and this one actually is this one's a challenge one. A 2012 penny. Why am I saying that? Because they actually changed the way pennies were made back in 1982. Before that, they actually made pennies out of pure copper. But when they finally figured out that the copper itself was worth more than what 1 penny is actually worth, they changed how pennies were made. They actually have the center of a penny made out of zinc, and then it's coated or plated with copper on the outside. So there's 2 substances there. There's copper and zinc, and they are distinctly separate. The middle is the zinc, the outer part is the copper. So it's not uniform throughout. So this would be an example of a heterogeneous mixture. Now, that's a difficult one. I would not ask you something like that on the exam. That's just for fun. But it's just to demonstrate that there are heterogeneous mixtures. Alright, table salt. You might know that table salt is also referred to as sodium chloride or NaCl. That is an example of a compound. Alright, next is a vanilla milkshake. So another example that might seem kind of weird. Vanilla milkshake. Think about that. Is it uniform throughout, before I ask that question, does it have the same properties and composition throughout? No, there's different things in there. There's the ice, there's the milk, there's all different kinds of things depending on how you make a vanilla milkshake. But there are different things that can be separated. So it is a mixture. What kind of mixture? Well, you might think it's the same throughout, but actually a vanilla milkshake is a heterogeneous mixture. And the reason why it's heterogeneous is because the milk particles are large enough that they are considered separate from the rest of the mixture itself. So you might be saying, man, you're throwing a lot of curveballs at me. And you're right. I'm throwing the curveballs at you here while we're together, so that way when you go and do problems on your own, they're easier and you're able to identify them a lot faster. I'm kind of talking a lot of the exceptions with you, so you're aware of them. Alright, salt water. You've heard me talk about this one. It's definitely a mixture, and it is uniform throughout. Okay, you look at salt water, it is uniform. And so this actually would be an example of a homogeneous mixture. And then chromium. Well, chromium is the element Cr on the periodic table, so by definition, that is an element. So that's just looking at some examples of classification of matter based on me giving descriptions. And once again, I want to tell you that a lot of these were very difficult examples. They are exceptions, or they are things that maybe weren't as clear. So I wanted to go through those with you together so that way you're familiar. But let's take a look at another example. What's another way I could ask that question? I could ask you to do it in particle form. So in this example, I'm giving you actual pictures, much like I did in the previous video, where we're looking at particle representations. And what I want you to do is, first step, classify whether it's going to be a pure substance or a mixture. And then after that, I want you to determine what is actually in the drawing. Does it contain elements? Does it contain molecules? And or does it contain compounds? Because it could contain all three, or it could contain just one or two. So you have to ask yourself what's actually in there. So let's do a few examples together, and then I'm going to let you do a few on your own. So in this first one, step one, does this represent a pure substance or a mixture? Well, I can see that that's to be treated as one chemical particle. And if I can see, it's the same throughout. All of them are the same substance. So because of that, this represents a pure substance. But then I have to ask myself, okay, what does it contain? Does it contain elements, molecules, or compounds? Well, it doesn't contain any elements. I mean, technically, yes, of course there's elements in there. Matter is made up of elements, but these particles don't represent individual elements. Instead, I see that this picture has molecules. Because remember, a molecule, I can't spell molecule apparently. Remember, molecules are at least two atoms, two or more atoms bonded together. And in these examples, 3 atoms are bonded together. So all of these are molecules. And more specifically, this picture also contains compounds. Because in order for there to be a compound, you have to have 2 or more different elements bonded together. And the black and white circles represent 2 different elements, and they're chemically bonded together. Alright, let's take a look at the second one. Second picture here. We have 2 types of atoms here, the black atoms and the white atoms here, but they're not chemically bonded together. You see how they're separate? So because there are different things that are not chemically bonded together, this would actually represent a mixture. Now, a mixture of what? What's in there? Well, the individual circles represent atoms, so the only thing that can be is elements. So, for example, the white circles could be sodium atoms, and the black circles could be gold atoms, just as an example. Nothing's chemically bonded in this, so it can't contain molecules or compounds. Finally, in this third one, this will be the last one we do together. If I take a look at this picture, this is definitely a mixture. I can see that there's 2 different types of particles in here. There's the bigger particles and then these smaller particles. So it is a mixture. A mixture of what? What's in there? Well, does it contain elements? Yes, it does. These white molecules here represent elements because it's 2 of the same atom bonded together. So maybe, for example, it's the hydrogen molecule, H2, as an example. So it does contain elements. Does it contain molecules? Yes, everything in there is a molecule. Everything in this picture is a molecule because it's 2 or more atoms bonded together. And then does it contain compounds? Yes, it does. It also contains compounds. It wouldn't be the white molecules. Okay, those aren't compounds. But these other particles, those are the compounds because it's got the 2 different colors. So go ahead and pause the video here and then go ahead and hit play to reveal the answers. Alright, so we have the answers here for the last 3. First one right here on the bottom, it is a mixture. We have 2 different types of particles in there, specifically molecules and compounds. There are no elements there. Second one on the bottom, it is a pure substance. You have the same atom throughout. Since nothing's chemically bonded, it can't be molecule or compound, so element is the only thing in there. And then finally we have pure substance because all these particles are the same. Those particles represent molecules and compounds. There are no individual isolated elements in that last picture. That wraps up section 2. We'll see you in section 3.